Step into a garage at dawn, and you immediately feel the difference. The heavy scent of oil and gasoline hangs in the dusty air. In front of you sits a massive block of tactile metal waiting to be wrenched on. Most modern vehicles have lost this sensation entirely. They are packed with digital screens and complex computer sensors, isolating the driver from the mechanics of the road and turning what used to be a machine into a quiet, sterilized appliance. The Royal Enfield Continental GT650 cuts directly against that trend. It is built as a deliberate return to raw, analog feedback. Delivering that specific mid-century riding experience requires physical engineering. You have to strip away the digital mediators and rely entirely on foundational mechanics. The blueprint for this mechanical purity comes directly from mid-century Britain, specifically the café racer subculture. Young riders in the 1950s and 60s used specific roadside transport cafes as the start and finish lines for high-speed, point-to-point sprints. These leather-clad racers built a distinct identity, rejecting mainstream norms to chase speed on public roads. To win those sprints, they needed pure acceleration. They aggressively removed mirrors, swapped heavy seats for minimal cowls, and lowered the handlebars to cut down every possible ounce of weight. The modern GT650 adopts this exact chassis geometry, taking a historical need for speed and translating it directly onto today's streets. When you push this bike out of the city and into steep mountain switchbacks, that engineering is put to the test. The core component driving the bike upward is its parallel twin engine, running on a 270-degree firing order. This diagram shows the internal kinematics of that engine block. Instead of firing simultaneously, the two pistons cycle with a specific uneven offset. This setup causes the engine's low-end torque, its immediate rotational force, to spike early, generating a signature aggressive rumble. That early torque delivery is exactly what a rider needs to power aggressively out of a steep uphill corner without losing momentum. But before exiting the turn, you have to survive the precise high-speed fraction of a second where the bike leans sharply into a hairpin. This graphic shows the forces at play. Gravity pulls down, but outward centrifugal force holds the machine up. The rider countersteers. Pushing left drops the chassis right. The entire combined weight relies on an incredibly small footprint of rubber, the contact patch. Loose gravel or a thin layer of mountain mist can easily break that delicate friction limit and cause the tires to slide out. Navigating a hairpin turn requires a real-time mathematical synchronization of engine torque, tire friction, and gyroscopic stability. As you burst out of the mountain mist and hit a long, sun-drenched coastal straightaway, the physical demands of the ride shift completely. The rider immediately changes their body language, tucking their chest tight against the fuel tank to chase top speed. This diagram demonstrates the fluid dynamics of that posture. By flattening against the tank, the rider drastically reduces their frontal surface area, allowing the heavy wall of wind resistance to flow smoothly over the helmet. The iconic low-slung silhouette of the Café Racer was designed as a rigorous, functional engineering solution to aerodynamic drag. Eventually, the road runs out. You cut the ignition at an ocean overlook, and the only sound left is the hot exhaust metal ticking as it cools in the sea breeze. The ride you just finished is a physical proof of concept. For miles, your own inputs, the internal combustion of the engine, and the laws of physics operated in total, unassisted harmony. In a landscape dominated by software and automation, the Continental GT650 represents a defiant survival of raw, unmediated mechanical interaction. The most exhilarating technology isn't always the most advanced. Sometimes it's the technology that connects you most deeply to the road beneath you.